All right, to start this off, let's take a look at our reference sheet. Okay, an exponential function looks like this. Y equals A, and the A is the initial value, times B, that's the growth or decay rate, to the power of X. So here, when I look, what's the initial value? The initial value is this number in this position. So in this case, it's 532. Okay, now, this right here, this is the growth or decay rate. Now, how do I decide what it is? Well, here's what I do. First, I take this, 0.92. I'm going to turn it into a percentage. It's 92%. And then I ask myself, how did I get to 92%? And here's the thing. I always start with 100. Always start with 100. Right? And the question is, how did I get from 100%? What happened to get me to 92%? So first I'm going to ask myself, did I add or subtract? Well, to get from 100 to 92, I'm going to have to subtract. Okay, and what do I have to subtract to get from 100 to 92? Now you could use your fingers. You could use a calculator too. You could do it like this. You could do 100 minus 92, and that's 8. So 100, I can also write that means the opposite is true, which is 100 minus 8 is 92. So basically to get from 100 to 92, what I'm doing is I'm subtracting 8%. So what does that tell me? That tells me the rate of, if I'm subtracting, that's decay. Okay, so this is the rate of decay is 8%. That tells me whatever I'm talking about, whether it's money or bunnies or whatever it is, I'm going to take this number and it's going to reduce by 8% every time period, whether it's days or years. Okay, so in this case, it's a decay rate of 8%. Let's take a look at this next one. Jordan buys a house that increases in value by 6% each year. It's worth $750,000 right now. Okay, write an equation to represent this. So remember, here's what our equation is going to look like. Y equals the initial value. What's the initial value? Oh, well, here it is. That's my A, because that's the starting value of the house. Here's my initial value. Now, it's going to be multiplied times the growth or decay rate, and then to the power of X. Okay, so the growth or decay rate is what I need to figure out here. And let me erase this just so I have a little bit of space. Don't leave myself too much. We're increasing in value by 6%. So I'm always starting with 100, right? We always start with 100. Always start with 100%. And I'm adding 6% because I'm increasing by 6%. So that's 106%. I'm going to change that to a decimal. And so that decimal goes right here. That is my growth rate. So this is my equation. How much will the house be worth in 20 years? Okay, that is where this X comes in, right? This X represents the number of time periods that are going by. In this case, we're talking about years. So what I'm going to put in my calculator is this equation with 20 as the exponent. So watch how that goes in. 750,000, make sure you get the correct number of zeros, times 1.06 to the power of 20. Okay, so I get this big, giant, long number. Yeah, that house is going to be worth a lot of money in 20 years. Okay, real estate is a good investment. So let's go ahead and write this down. And I'm just going to be careful to get all the numbers. So it's 240,535,1. So this is actually $2.4 million pretty much. Now it says round to the nearest cent. So remember, the nearest cent, like think about the price on something. Like if something's $7.99, right? The nearest cent is 2 decimal places. So I'm going 2 decimal places. So I'm going to go 1, 2 after the decimal. Now this is a 4. Let's say it was a 5. I would round up, but because it is just a silly old 4, okay, 5 or higher, I round up. But this to the nearest cent looks like this. All right. Let's do one more. There are 38,000 people in a stadium at the end of a soccer game. Okay, each minute, 15% of the crowd leaves. Okay, so crowd's leaving at the end of the soccer game. Let's write our equation. Now we know that our initial value comes first. So we're going to write our initial value. The initial value is that there's 38,000 people in a soccer stadium. Okay, now, what's the growth or decay rate? In this case, we're decaying, right? The crowd is leaving. So we always start at 100%, always start at 100%. And then we are subtracting 15% each minute, right? So the crowd is leaving the stadium pretty quick. That's 85%, and that is 0.85. So here is my equation. And let's go ahead and put this in our calculator, right? Because what I'm doing, and I'm going to get set up, is I'm going to put this in my calculator, 38,000 people decaying at a rate of 15% after 30 minutes. 30 minutes, look, half an hour, that's 30 minutes. Remember this, each minute, so this is minutes up here. After 30 minutes, how many people are going to be left? Not too much, right? The game ends, most of the crowd leaves. So after half an hour, there's just going to be not too many people left, right? We're talking about in the hundreds instead of in the thousands. Now it says round to the nearest whole number, right? Because we can't have a part of a person. So nearest whole number, we're going to cut that off at this decimal point, right? That's a whole number right there. Now, because this is 0.9, it's going to round this number up. So instead of this being 289 people, we're going to write 290 people. Okay, there's 290 people left in that stadium.